Hi, Andy, name is Priyanka. Welcome to Learning Lens channel. Today we are going to discuss exercise 2.2 second problem. So in that second problem, bits we are going to discuss. So find a quadratic polynomial. We need to find the quadratic polynomial with the given numbers. So what are the given numbers here? This is sum of the zeros and this is the product of the zeros. So given here sum and product of the zeros. So we should assume one as the sum of the roots and the other as the product of the roots. So using this sum and product of the roots, we need to find the quadratic equation. Okay. So what we should take alpha plus beta. So alpha plus beta value is sum of roots. So sum of roots how much? 1 by 4. So alpha plus beta is sum of roots, that is 1 by 4. So alpha beta. What is alpha beta? Product of roots. So product of roots is minus 1. So what is alpha beta? Product of roots. So product, that is minus 1. So now what is the quadratic equation? Now quadratic equation. Now quadratic equation for ax square plus bx plus c is k into x square minus alpha plus beta into x plus alpha beta. So the quadratic equation for ax square plus bx plus c is k into x square minus alpha plus beta into x plus alpha beta. So this is the general form of the quadratic equation. So what is alpha plus beta value here given? 1 by 4 into x plus alpha beta value is given as here minus 1. So k into x square minus 1 by 4 into x plus into minus is minus 1. Okay. So now let's solve this equation. So k into, so here 4. In the denominator 4 is there. So these two numbers are not having any denominator. So let's assume it as 1. So what is the LCM for 1 and 4? 4 only. So k into, so LCM is 4. So in 4, so in one table 4 how many times? 4 times. So 4 into x square minus, so in 4 table 4 one time only, 1 into x, that is x, and in one table 4 and in one table 4 how many times? 4 times, that is minus 4. So what is the denominator we got here? 4. So now I will explain why we wrote 4 here. Okay. So if any denominator is there like 4, 3 and so on, so to cancel out that we are writing k. So let us assume k value as 4. So now what happens? 4 into 4x square minus x minus 4 by 4. So 4 and 4 get cancelled. So 4x square minus x minus 4. Okay. So suppose here if the denominator is 3. So what we'll write here? K value as 3. So if the denominator is 5 means we will write the k value as 5. Like that we will write. Suppose if the denominator is minus 1, we will write the k value as 1. Okay. We will not consider the negative values, just the numbers only we will consider. The digits only we will consider, not the signs. Okay. So in second problem, second bit we are going to discuss. So what is the given? Sum and product of zeros. So what are these two numbers given? Sum and product of the zeros. So alpha plus beta is nothing but sum of roots. That is root 2. Next, alpha beta is nothing but product of roots. Product of roots. That is 1 by 3. Okay. Now the general form of the quadratic equation. Now quadratic equation. Now quadratic equation for ax square plus bx plus c. So we are writing the quadratic equation for ax square plus bx plus c. That is k into x square minus alpha plus beta into x plus alpha beta. So what is the quadratic equation for ax square plus bx plus c? K into x square minus alpha plus beta into x plus alpha beta. So what is the alpha plus beta value here? Root 2. Root 2 into x. So in the place of alpha plus beta, I am writing this value, root 2. So what is alpha beta? 1 by 3. So in the place of alpha beta, I am writing 1 by 3. So here in the denominator, 3 is there. So here no denominator means let us assume as 1. So what is the LCM for 1 and 3? So LCM for 1 and 3. 1 1 is 1, 3 1 is 3. So 1 into 3, that is 3. So LCM for 1 and 3 is 3. So if you have doubt in taking LCM, so let's have a glance into that. Okay. So 3. So in one table 3 how many times? 3 times. So 3 into x square minus, again in one table 3 how many times? 3 times. 3 into root 2 is 3 root 2x plus, in 3 table 3 how many times? 1 time. So 1. So what is the denominator we got here? 3. So what we should assume the k value as? 3. Why? Because what is the denominator? We should assume the k value, that only. So k's value is 3. So let us assume k as 3. So 3 into, so I am assuming the k value is 3. So 3 into 3x square minus 3 root 2 into x plus 1 by 3. So 3 numerator and denominator gets cancelled. So 3x square minus 3 root 2 into x plus 1. So now what is the quadratic equation we have got? 3x square minus 3 root 2 into x plus 1. Understood? So now third problem. So third bit in the second problem. So what is given again? The sum and product of the zeros. So one value is given as a sum. So this is the sum and this is the product. So using the sum and product we need to find the quadratic equation. So alpha plus beta, that is sum of roots. How much? 0. So alpha beta is root 5, that is product of roots. Product of roots. So according to the given value I am taking. So alpha plus beta value is 0, that is sum of the roots. And alpha beta is root 5, that is product of the roots. Now quadratic equation for ax square plus bx plus c is. So what is the quadratic equation of the general form for ax square plus bx plus c? We already know that k into x square minus alpha plus beta into x plus alpha beta. So what is the quadratic equation for ax square plus bx plus c? K into x square minus alpha plus beta into x plus alpha beta. So what is the alpha plus beta value given here? 0. So 0 into x plus alpha beta value is root 5. So here alpha plus beta value is 0 and alpha beta value is root 5. So here no denominator is there. So we can take the k value as 1. So 1 into x square plus root 5. So now what is the quadratic equation for these two sum and product of the zeros? 1 into x square plus root 5. That is x square plus root 5. Understood? So next problem 1 comma 1. So what is the sum given here? So sum of the zeros is 1 and product of the zeros is given 1. So for this 1 comma 1 we need to find the quadratic equation. Okay. So alpha plus beta, that is sum of roots. So sum of the roots is alpha plus beta, that is given as 1. So what is given as alpha plus beta? Sum of the roots, that is 1. And alpha beta, that is product of roots. So what is the product of roots given here? So product of roots is here 1. So now we need to write the general form of the quadratic equation. Now general form of quadratic equation is k into x square minus alpha plus beta into x plus alpha beta. So k into x square minus, what is the alpha plus beta value we have got given here? 1. 1 into x plus, what is alpha beta value here given? 1. So So nothing denominator is there. So no denominator is there. We can write k value as 1. So 1 into k x square. So 1 into x square minus 1x plus 1. So that is x square minus 1x plus 1. So what is the quadratic equation we have got here? X square minus 1x plus 1. Understood? Okay. So next problem, fifth one, that is minus 1 by 4 comma 1 by 4. So what is the sum of the zeros? Minus 1 by 4. And what is the product of the zeros? 1 by 4. So sum of roots is alpha plus beta. So what is the sum of the roots given? Minus 1 by 4. And product of roots. What is the product of roots? Alpha beta, that is 1 by 4. So now we need to write the general form of the quadratic equation for ax square plus bx plus c. General form of quadratic equation for ax square plus bx plus c is k into x square minus alpha plus beta into x plus alpha beta. So what is alpha plus beta value we have got here? Minus 1 by 4. So minus 1 by 4 into x. And what is the alpha beta value given here? 1 by 4. So what is the LCM here? So nothing is there. I am writing it as 1. So what is the LCM for 1 and 4? 4. So k into LCM is 4. So in one table 4 how many times? 4 times. So 4 into x square minus. So in 4 table 4 how many times? 1 time. So 1 into x is 1x. Plus in 4 table again 4 how many times? 1 time. Plus 1. So k into 4x square minus 1x plus 1 by 4. So here the denominator value is 4. So to cancel out we should assume the k value as 4. So I am assuming the k value as 4. Now 4x square minus 1x plus 1 by 4. So 4 and 4 get cancelled. Now what is the quadratic equation? 4x square minus 1x plus 1. So now the quadratic equation for this sum is 4x square minus x plus 1.